Chapter 11, Section 1, Circumference and Arc Length. First of all, vocabulary word, circumference. The circumference of a circle is the distance around the circle. If you had a circle, and you started at one point and you walked all the way around that circle, you would get a distance around the circle. So our first theorem, the circumference C of a circle is C equals pi d, or C equals 2 pi r, where d is the diameter of the circle and r is the radius of the circle. Pi is a button on your calculator, which you can approximate to 3.14. It's also something you can eat, usually really good with ice cream on top, a little bit warm, maybe some apple pie. First example, find the indicated measures. If I have a circumference of a circle with a radius of 9 centimeters, I would use circumference equals 2 pi r. So 2 times pi times 9. And I usually use that button on my calculator. I don't round it. I keep everything as exact as possible. So in the graphing calculators, you have to find it. If you're having trouble, let me know tomorrow. But I got 56.5 centimeters. Find the indicated measures. A radius of a circle with a circumference of 26 meters. So we're looking for the radius. I know that the circumference is 26 meters, and I'm looking for the radius. So I'm going to solve for r. 26 divided by 2 divided by pi. You get radius equals 4.14. It doesn't tell you how many spots to round to past the decimal, so use your best judgment. Example 2. Use circumference to find distance traveled. The dimensions of a car tire is shown at the right. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So remember, circumference is distance around. So every time that tire makes a revolution, it travels a certain distance. So you think, if the tire's going this way down the street, it's going to roll, and each time it rolls, it makes a distance. So 1 revolution would be 1 distance around the tire. 2 revolutions would be 2 distances around the tire. 3 revolutions, 4, 5. It's almost like you're cutting the tire and flattening it out to make a straight, to like peel it flat to see the total distance of the tire. Make some room to actually do some work. So if we know the circumference around the tire, then we can get the distance of 1 revolution. Okay. So the distance traveled equals the number of revolutions times the circumference. Can't spell circumference. So let's do the circumference. Okay, these are the dimensions of the tire. I could do the diameter one from one end to the other. I get 15 plus 5.5 plus 5.5. That's 11 plus 15 is 26. Sorry, I had to sneeze. Circumference equals pi d. Pi times 26. Pi times 26. 81.7 inches. Okay, 15 revolutions times 81.7. 1,225.2 inches. That really doesn't make any sense, and it says to the nearest foot, so I'm going to divide that by 12 to get 102, it says to the nearest foot, so we round there, 102 feet, approximately. All right, you try one. I'm going to push pause, try this one on your own, and see if you can do it. If not, we have something to discuss tomorrow, so make sure you can get these answers on your own. Okay, there you go. Push pause and check it out. Let me know if you have questions. Second, you try. Push and pause. Try it on your own. Okay, on this one, notice that your diameter is given to you in inches, and the distance the tire travels is in feet. So right here, I converted my inches to feet, which, yikes. I had 87.96 inches. I divided by 12 inches per foot and got 7.33 feet. So that's in feet, that's in feet. It gives me my answer in revolutions. All right, next part. An arc length is a portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length in linear units. So let's review just a tad bit. This is a circle. Okay, the arc is a part of a circle. An arc is always associated with some kind of angle with the circle. An arc can be given in degrees. That's the measure of the arc, or in a length, a linear unit length. Like if I measured this with a string, it would be in length. But if I had degrees, it would be the measure of the arc in degrees, or the measure of the arc in length. There's a difference. So make sure you know what the problem is asking for so you know how to find the answer. So our arc length corollary. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So the arc length, this is your linear length. The arc length is your arc length divided by 2 pi r is equal to your measurement of the arc, which is in degrees, divided by 360. Okay? Linear measurement of the arc divided by 2 pi r is equal to the degrees of the arc divided by 360. It's a proportion. Okay? You think about the degrees divided by 360 is equal to the linear length divided by 2 pi r, which is your circumference. So degrees over degrees equals linear length divided by circumference. It sort of makes sense. So if you take this and solve for arc length, you would multiply both sides by 2 pi r. Let's just write that out. I have arc length over 2 pi r equals the degrees of the arc over 360. If I'm solving for arc length, I spelled that wrong. I would multiply both sides by 2 pi r. Okay, these cross out. I'm left with arc length equals the measurement of AB in degrees divided by 360 times 2 pi r. Let's use it. Find the length of each red arc. Okay, so if we want the length of the red arc, we learned that if this is a central angle, okay, geometry students pay attention, this is your central angle. If it's 60 degrees, the degrees of this arc is also 60 degrees. Okay, this is a central angle, so if angle P is 60 degrees, then the measurement of this arc is also 60 degrees. Okay, now let's use that corollary we just learned. So the arc length equals the measurement of the arc over 360 times 2 pi r, where r is 8. So turn my calculator, 60 divided by 360 equals 0.167 times 2 times pi times 8 times 2 times pi times 8. So that is the length of the arc. Try the next one. Alright, same type of problem. This is a central angle. So if angle Q is 60 degrees, then the measurement of EF is also 60 degrees. So we're going to do 60 over 360 times 2 times pi times 11. .5 centimeters. Okay, well, again, here I have a central angle of 120, so the arc is also 120. 120 over 360 times 2 times pi times radius is also 11. .0 centimeters. That's it. Oh, one more. My bad. Okay, find the indicated measure. So here we have the length of the arc. The length of the arc is 4.19. So if you remember the corollary, I'm turning back one page, it says the arc length of AB, or in this case XY, over, well, let's write it up here. The arc length over 2 pi r equals the measurement of the arc in degrees. In this case, it's XY over 360. So we're actually trying to solve for the circumference, which is right here. Circumference equals 2 pi r. So if I want to get the 2 pi r by itself, I'm going to say arc length equals the measurement of the arc over 360 times 2 pi r, which is your circumference. Multiply both sides by 360. Cancels those out. I'm left with 360 times arc length equals the measurement of the arc times the circumference. Divide both sides by the measurement of the arc. And I'm going to switch the page. So write this down. I'm switching pages. I'm going to add a slide. Okay. So our final equation is, if we're solving for circumference, arc length times 360 all over the measurement of the arc. And that equals 2 pi r, which is your circumference. So I can actually cross that out and say just plain old circumference. So let's plug in what we know. We know the arc length of xy is 4.19 times 360, and the measurement of the arc, the central angle is 40, so the degrees in the arc is also 40. Okay, 4.19 times 360 divided by 40 means our circumference is 37.71 inches. Phew. Okay, find the indicated measure. We're going to try to find the measure of the degrees of RS. Okay, so we know the length of the arc, which is 44, and we know the radius. So we're going to use that equation we just rearranged. The measurement of the arc times 360 divided by, divided by the, we don't know the arc length. We're trying to find it. Oh, for goodness sakes. Erase. Let's write down the original corollary. Okay? The original corollary says arc length over 2 pi r equals the measurement of the arc, which is RS. Ooh, that was a close one. Oh, hold on. Start over. Arc length over 2 pi r equals the measurement of the arc in degrees over 360. Okay, this is what we're trying to solve for. So I'm going to multiply both sides by 360 because it cancels those. All right, let's plug in what we know. I know 360 times the arc length is 44 divided by 2 times pi times 15.28. 360 times 44 equals, divide by 2, and pi, and 15.28. I got 164.9 meters. Let's think about that. It's a degree, so that sort of makes sense. It's a pretty big degree, okay? It's less than 180 because 180 would be diameter. So that makes sense. It's always good to look back at your problem to see if it makes sense. You try. Find the length of arc PQ. We're trying to find the length of this right here. Okay, so if you go back to your corollary, arc length over 2 pi r equals the measurement of the arc in degrees over 360. Okay, go ahead and try. I'm going to push pause. Okay, got the answer. Notice that our circumference part is always 2 pi r, but here our measurement is in a diameter, so I didn't use 2 pi r, I used pi d. Alright, here we're trying to find the circumference. Circumference is pi d, or 2 pi r. It looks like we have the distance, the length of this arc right here. And we have the degrees associated with it, but we do not know the radius. But we can figure out the radius. So if we use our original equation, arc length over 2 pi r, or over circumference, equals the measurement of the arc. Okay, this would be the major arc LM, because the only one we have the degrees for, over 360. So really we are trying to solve for this. So we did this a few slides ago, and we got 2 pi r equals arc length times 360 over the measurement of LM in degrees, and that's the major. This is what we're talking about right here. Let's plug it all in. 61.26 times 360 over the measurement of the arc, which is 270 degrees. Do some math, crunch some numbers, fire up the calculator. I got 81.68. And we just solved for the circumference, so that is our circumference in meters. Okay, that was a tough one. Okay, rewind and watch that again if that's confusing to you. Okay, now let's find the radius. We know the linear distance of this arc. We know the degrees associated with it. The inner angle is 150, so the degrees of this is also 150. We're going to use the equation we just used. 2 pi r equals the arc length times 360 over the measurement of the degrees of the arc. And I keep saying AC, and I keep erasing AC and putting in what they use, which in this case is EF. So let's do this first. Arc length is 10.5 times 360 divided by 150. I get 25.2 equals 2 pi r. I'm actually looking for radius, so I'm going to divide both sides by 2 pi. And I get a radius of 4.01 feet. That corollary, we really have to be able to move that around and solve for different things in it, because we've just used it 3 different ways. All right, example 5. The curves at the ends of the track shown are 180 degree arcs of circles. The radius of the arc for a runner on the red path shown is 36.8 meters. About how far does this runner travel to go once around the track, round to the nearest tenth of a meter? So we really are trying to figure out the linear length of that arc. Luckily, we know a lot about a circle. Okay, this is 180 degrees, right? So, arc length equals the measurement of the arc. I'm just going to use the one from the corollary, times 2 pi r over 360. Okay, let me erase this. Okay, the angle, the measurement of the arc in degrees is 180 degrees, because it's half a circle, times 2 pi, the radius is 36.8, because that's given, divide by 360. And I get 115.6. So this distance right here is 115.6 plus 84.39 right there, plus 84.39, which is right there, plus 115.6, which is right there. That should give us our total length. And I got 400 meters, which if you run track is true, which is why when you're running, you try your darndest to stay as close to the middle as possible so that you don't have to run further to go once around the track. In example 5, the radius of the arc for a runner on the blue path is 44.02 meters. How far does this runner travel to go once around the track? Okay, hold on, I'm going to push pause and bring that picture up. Okay, so let's figure it out. Now we're on the runner in blue. So we want arc length, oops, sorry about that. Get my pen out. Arc length equals the measurement of the arc in degrees times 2 pi r over 360. The measurement in arc in degrees is again 180 because it's a semicircle. I don't know why I just wrote plus. So measurement of arc AB times 2 times pi times the radius is 44.02 all over 360. Let's see what that gives us. $138.3. So I have 2 of those. I'm going to do this a little bit different. Plus the straight lengths. Okay, so multiply this by 2. Add the straight lengths. And I got 445.4 meters. That's quite a bit more for that poor person running along the outside of the track. Yeah, that's the right answer. Okay, that's all we have. Try your daily homework quiz. It's an easy 2 points, guys. Okay, it really does help. So first page, second page, third, fourth, fifth, one more, sixth. Okay, good job today.